So let's speak. Let's say a few words about link budget for the quantum communication satellites, or for the quantum systems in general, for the quantum communication systems. So so the main idea is, I think, the link budget equation itself is borrowed from the classical communications. So here we have a few terms, as for example, as divergence due to diffraction. So when the beam actually the particles are, when the beam travels, it diffract, divergence to turbulence, and we would have some also term due to atmospheric attenuation, and we would have also some term to the Poynting loss itself. And yeah, so this actually this equation is needed to actually estimate afterwards the key rate at which we can share the securely share the key itself. So so what does actually the turbulence? Here we have a few terms, and I think maybe most nefarious of this would be actually the link distance itself, that would degrade the link, but also the turbulence. So here you can see this point spread function for the divergence only limited system. So for the diffraction only limited system, sorry, and also you would have this spread function that would be limited by the turbulence itself. So and what is a turbulence? So turbulence, you can think about turbulence is this kind of eddies in atmosphere that are generated by the varying atmospheric conditions in the atmosphere. So varying temperature, air pressure, and wind would create this kind of would split atmosphere into different into smaller layers of the atmosphere, which they're called eddies. And the way we actually describe turbulence is by this R0 value, which is called a freeze parameter. And well, it's proportional to the wavelength at which you communicate. And it's also important to know that it's actually for the when you actually traverse when you perform communication at some elevation angle, you actually communicate over greater distances Therefore, you transfer more layers of more turbulent layers. Therefore, your link degrades.